Okay, in this video we're going to do question 1 so far of the practice problems. So you can see it says given the function f of x equals 2x cubed minus 15x squared plus 36x minus 24. That's a cubic function. We're going to find all the critical values, and then we're going to conduct both a first and second derivative test with a comment, and then ultimately provide a sketch of the function. And they want us to include the y-intercept, which is right here, the x-intercepts, which you're going to have to get, the maximum point and the minimum point. So that's the x and y values of the max and of the min. So let's get started. So the first thing we're going to do is write down our function. So f of x, I'm just going to write it down. You should be writing it down also. And notice the notation you want to have. Okay, let's take our first derivative. And I have 3 times 2 is 6x squared minus 30x plus 36. While I'm here, I'm going to take my second derivative, and that's going to be 12x minus 30. Alright, now that I have our derivatives done, why don't we go ahead and we're going to work with our first derivative. So I'm just going to see if I can take this. Okay, so copy that, and we'll put it on the next page. Alright, so now the first thing I'm going to do is we're going to set this equal to 0. So here it is equal to 0, and I'm looking at that as a hard factoring, but then I say, wait a second, I can factor out a 6, so I'm going to do that first. So I get x squared minus 5x plus 6, and that is easier for me to factor. So it multiplies to 6 and adds to negative 5, and that would be 2 and 3, both of them being negative. Okay, don't mess up on this part because this factoring problem is one that is frequently incorrect. Whenever you factor, you want to always, just mentally, if nothing else, make sure that your factors that you have selected actually work in your problem. And in this case it does. The multiplies to positive 6, and it's going to add to negative 5, so I know I'm good. Always do that step, because everything else you do from this point forward is based upon those factors. So my critical values I obtain by setting my factors equal to 0. I only have 2 factors. 6 is not a factor because there is no x involved there. So my 2 critical values are x equals 2, x equals 3. Again, I got those by setting my factors equal to 0. So, next thing, why don't we try to set up our first derivative test. So here will be the first derivative test info. And on my number line, I put the 2 and the 3, and I'm going to indicate I'm checking the first derivative. So pick a number to the left of 2. 0 is a nice number. If I plug 0 in here in my factored form, I get 6 times a negative times another negative, which is going to give me a positive, and therefore the value to the left of 2 is positive. Now I'm going to have to pick 2.5 in between 2 and 3. If I plug in 2.5 here, it's positive. Here it's going to be negative. So a positive times a negative is a negative, so that's going to be negative. Now let's check to the right of 3. If I plug 4 in here, it's positive. I put 4 in here, it's positive. Positive times a positive is indeed a positive. So this is the shape I'm seeing. I'm seeing that the slope is positive here, 0 here, negative here, and then back to positive. So it appears to me that we will have a max at the critical value of 2 and a min at the critical value of 3. So I'm going to have to write about that because no sign chart is complete without having a statement. So my statement was going to be at CV of 2, the slope changes from positive to negative, and therefore I have a max Okay, at the CV of 3, the slope changes from negative to positive, and that gives me a min. All right, now why don't we go ahead and on the next page we will do the second derivative test. All right, so let's do that. Let me set that up and then I'll turn the video back on. Okay, so everything is set up for my second derivative test. I am checking my critical values, so I've set up my chart already. So if I plug 2 into my second derivative, 2 times 12 is 24. 24 minus 30 will be a negative, and therefore I have a negative sign above the 2. Let's try the 3. Plug the 3 in to the second derivative. I get 36 minus 30, which is going to be a positive. So let's think about this. If I have a negative for my second derivative above the 2, then that means that's my max. If I have a positive above the 3, then that means that's my min. Okay, so I have a max and a min. Now I'm ready for my statement. Okay, at the critical value of 2, f prime prime of 2 is less than 0, therefore I am concave down, which leads to a max. All right, so now I'm going to try to fit in my second statement. So at a CV of 3, f prime prime of 3 is greater, let me just fix that, is greater than 0, so that means I am concave up, which yields a min. Remember, you always want to have a conclusion when you have these statements. It's not sufficient to say that the second derivative is negative or the second derivative is positive. We're trying to test if we have max and mins, so you always should end your statement with whether this proves you have a max or a min. All right, so now we've done first and second derivative tests, and we're going to work on doing the sketch. So I'll do that on the next page. Okay, at this point we're ready to graph. So I've copied down the original function here on this slide. I know the max happens where x is 2. I am then going to plug the 2 into the original function to get the y value. So what I do, when I get that, it's going to be 4. So 2 comma 4 is the max. So notice I'm plugging it back in the original function. The min is going to be 3 comma f of 3, and when I plug it in, I end up getting, well, I want to write it here, so let me undo that. So when I plug the min in, my min ends up being 3 comma 3. So just verify that you're getting the same mins. So I can start plotting some of these points. So right here is going to be 2 comma 4, and then here is going to be 3 comma 3. All right, the y-intercept I could get by just looking at the original function. I see that if x is 0, y will be negative 24. So, and it always happens, on the y-axis. That's why it's called a y-intercept. So that's going to be here. I then used my calculator, and I got my x-intercept, which ends up being a little bit to the right of 1. Whoops, sorry. And it's at 1.09. So now I'm ready to sketch my graph. I'm going to come up here, I'm going to go through there, come down, and then I'm not sure where it goes after this. So let's think about this. If it's a cubic, it's going to go back up, stay up. So this is going to stay up. So this is our graph. I can indicate the max and the min, and I have a nice smooth curve. So that completes this problem. Make sure you could recreate this yourself. Okay, in problem number 2, they're asking you to identify certain points on this graph. So notice that this is the graph of the first derivative. all right, not of the original function. And then the purple is the graph of the second derivative. So looking at points A, B, and C, since this is a first derivative graph, what I know is that I have critical values at -2, 2. I know these are my critical values because that's where the first derivative equals 0. So now let's go ahead and do our chart. So to the left of -2, the slope is positive. To the right of -2, the slope is negative, just reading off the y-axis. And then to the right of +2, the slope is positive. So that's my test. What does this tell me about my shape of the curve? Well, if this is positive here, that means it's going to be going up, and then here's negative, and then positive again. So that means that A is going to be a max. And that's what you would identify on the line below. C is going to be a min by virtue of that sign chart. Now, look at this point right here. What is that? Well, that is the vertex of the first derivative. It's also the root of the second derivative. So B is the inflection point. So it's the inflection point of the original function. And is it really the whole inflection point? So I will say it's the, so let me rewrite this a little bit. So eliminate that for a minute. It's the x value of the inflection point. So that's what B is. Okay, so we have max, x value of inflection point, and here really it's the x value of the max and the x value of the min. Alright, so you should be able to identify those kinds of points. Always remember to look and see what the graphs are that you are observing. If you are observing a first derivative, you can really easily turn that into a sign chart, just like I've done here. And again, for each of these answers, you are really only observing the x value of the various components of the function. Okay, in this problem, they're asking us something we've worked on in the past. So they want us to write the equation of the tangent line, drawn to the graph of f of x at x equals 2. And they want us to provide a sketch. So the second I see write the equation of the tangent line, what I'm going to always tell you to do is to give yourself this. And then figure out where you're going to go from there. Alright, if you're going to write the equation of a tangent line drawn to that graph, they give you the fact that x is 2. So that x is your x1. So now you're done with that. You still need the slope, and that's the slope at the x of 2. So that's the first derivative of f of x evaluated at 2. And you are also going to need your y1. Now, I would suggest strongly that before you start taking any derivatives, go ahead and get your y1 by plugging 2 into the original function. So you can certainly do this on in your graphing calculator. So this is I'm going to set it up so you see what I'm doing. Okay, so if you were to evaluate it at 2, you would find that f of 2 is going to be -2. So now you have another value. You've just found out that your y1 is -2. So our next mission is to figure out the slope. So now you're going to take the derivative. So the derivative with respect to x of that function is 3x squared minus 8x plus 0. So done. So what I want to do is not set it equal to 0 and find critical values. We're not doing this now. Don't go on autopilot and do that. What you're going to do is figure out what the slope is when x is 2. So this is going to be 2 squared, and then I have 8 times 2. So what I find is that my slope will be -4. So just check that. Okay, so now I have all 3 values. So the equation of the line drawn tangent to the graph at x equals 2 is y minus a minus 2, so that's y plus 2, equals negative 4, and then x minus 2. So that's what you should be getting. Okay, so make sure that you're confident with all the components. They also ask you for a little sketch. So you can use your graphing calculator and get a sketch. Now when they say sketch, they don't mean that you have to graph it exactly, but you should have some landmarks. So if I'm going up by, say, 2's, I see that I have a y-intercept right there, and I see it's a cubic, so it looks to me like on my graphing calculator when I look, this is kind of the shape, and if that's my shape, they want the tangent line, so why don't I change color? And I want the tangent line at x is 2, so that's going to be down here, so let's just say that x is 2 right there, and that's the point 2, negative 2, by the way, that it's intersecting, and then sketch in your tangent line. So does this make sense to you? The tangent line has a negative slope, so that's consistent with what I had up here, and the intersection point is 2, negative 2, so I'm good there as well. So that completes the problem.